Today I will be doing a bit of trick and we'll be focusing more on general solutions, equations in essence. Now, what do we do when we have 2 cos squared x minus sine x minus 1 is equals to 0? You will notice that this is basically a trinomial with the highest degree of 2. However, I cannot be able to factorize with different ratios. I've got cos and sine. I need to get rid of one of them. And there's no way I can change sine x because cos x is squared. That gives me a little bit of hope. And I can simply manipulate that cos squared x and find or change it to sine x. Now, hint, since you cannot change sine, change cosine to sine. For this type of equation, try to change what you can change to what you cannot change. Okay, so we need to change cos because we can change it, but we need to change it to sine, which is what we cannot change. And we are simply going to use this identity, which specify that sine squared x plus cos squared x is equals to 1. Manipulate this and solve for cos squared x, and you will notice that cos squared x will be equal to 1 minus sine squared x. And that leads me closer to what I need. So all I know is that this cos squared x here is equals to 1 minus sine squared x. All I'm going to do is that where there is cos squared x, I'm going to substitute this 1 minus sine squared x. Okay. In place of cos squared x, I'm simply going to substitute that 1 minus sine squared x. And that's what I did. So where there was cos squared x, I now have 1 minus sine squared x. The 2 that was outside is still there. Still multiplied by cos squared x, but the only difference is that cos squared x, I have changed it to 1 minus sine squared x. Now the 2 that is outside the bracket, because it's multiplied with the bracket, I will need to multiply the bracket out with that 2. I will first multiply and when I distribute that 2 inside the brackets, I will have 2 times 1, which is 2. 2 times negative sine squared x will give me 2 sine squared x. Like terms with like terms. Those 2 minus 1 will give me 1, and this is what I will end up with. Get rid of this negative. By multiplying all the terms with negative 1, you will end up having 2 sine squared x plus sine x minus 1. And that is pretty much easy. It looks like a very simple trinomial to factorize, where the factors of 2 sine squared x will be 2 sine x times sine x. And in the first bracket, I will have 2 sine x minus 1. In the second bracket, I'll have sine x plus 1. Now, you should be able to factorize that by now, and you should be mastering how to factorize trinomials. Now, since these factors are multiplied and they are equal to 0, what you can do is take each factor and equate to 0. And once you have equated each factor to 0, isolate the ratio. And when you isolate the ratio, you will be left with the ratio and coupler numbers, which is just a linear. All I did here, I simply solved for the first equation, which was 2 sine x minus 1. When you isolate the ratio, you will have sine x is equals to 1 over 2, and simply find the inverse sine of 1 over 2. And when you find the inverse sine of 1 over 2, you will have to add 360 degrees times k, where k is an element of integers. But remember, when you use the sine ratio, it has two parts of the formula. The second part of the formula, you need to take the inverse sine of 1 over 2 and subtract it from 180 degrees. Okay, now what is the inverse sine of 1 over 2? Let us check. X sine of 1 over 2, how much does it give us? If you know your special angles, this should be quite easy. It'll simply give you 30 degrees, and that will be the angle. You'll end up having 30 degrees plus 360 degrees times k, where k is an element of integers. And then that 30 degrees, you need to subtract it from 180. And when you subtract 30 degrees from 180, you will get 150 degrees plus 360 degrees times k, where k is an element of integers. All right, that is the first part. The second part, which is the second vector, we had sine x plus 1 is equals to 0. When you solve for sine x will be equals to -1. And then to solve for x, you'll have to find arc sine of -1 plus 360 degrees times k, where k is an element of integers. But it has two parts. Whenever you use the sine ratio, remember it has two parts. The other part is where you take 180 degrees minus arc sine of -1. But arc sine of -1, let's calculate it quickly and see how much that will give us. Arc sine of -1 gives us -90 degrees. Okay, so when you take 180 degrees, and I will start with the first one. The first one will be -90 degrees plus 360. The second part of the ratio of the formula will be 180 degrees minus -90 degrees. That will give us 270. Please note that when you take negative minus negative, will simply, when you take a positive, in this case, our positive was 180, but you're minusing a -90, and that will give you positive 270 degrees. And that's where you will stop with your solution. This is the general solution. Unless you've been given an interval to work with, you will substitute any integer. Remember, integers cannot be decimals, they cannot be fractions. It is simply your natural numbers plus the negative components of those natural numbers. They should, those are the only values you can substitute into k. And whatever angle you get must be an angle that is between the ratios that you are given. I hope that is clear. What's all?